Hello and welcome back to part 2 of 5.5 U-substitution. We're going to talk about back substitution. This is a very short presentation here. And then we're going to transition into the definite integrals, because we also have to learn, in addition to U-sub, we have to learn how to transform the limits, and I'll talk about that. So just a quick, this is a trick that is rare. It pops up, you know, once or twice in Calc1 and once or twice differential equations for the particular type of the integral. Back sub. So integral of x over x minus 2 dx. It is very important to see that this integral does not have function derivative pair. The derivative of x is 1. There is no x squared to produce any of the x's, right? So this seems as it is not a substitution problem at all. But in some cases, we can force a little bit and it works. So if I go and say u equals x minus 2, right, then clearly du is equal to dx, right, because the derivative of x minus 2 is just 1. And if you try to plug all of the stuff in, you have x over u du. Now clearly the x that stayed, that survived, is an issue. But what you can do is you can solve your u substitution for x and get x equals u plus 2 and plug that in there. So that's that back substitution part, right? This one. So now what I have is the integral of u plus 2 over u du, which I can split into two integrals because I have the common denominator. So u over u plus 2 over u with parentheses and the du. And finally that is integral of 1 du plus integral of, kick 2 outside, 1 over u du. What is the integral of the first one? Yeah, u. Yep, u. And then what's the integral of the second one? Absolute u. Yeah, this absolute must be there. And then you have plus c. We know that our u was x minus 2, so the whole thing is x minus 2 plus 2 ln absolute x minus 2 plus c. Now, this is the one that I'm going to box. But most likely, if you go to the Wolfram Alpha, the Mathematica, and so on, you are going to get x plus 2 ln x minus 2 plus c without this negative 2. And the reason is it gets absorbed in the constant. Yeah. Because this constant is some number that is not determined yet. So you can also see, so if your problem, you're checking these things online with the software, and your solution differs than a solution that the computer gives you by add or subtract a number, it's absorbed in a constant. So that's okay. You know, if you really want to drive someone crazy, you can just go and say, well, this is the answer, and then you just add plus cosine squared x plus sine squared x, right, just out of nowhere. It's still a valid solution. Yeah, because this is 1, it gets absorbed in a constant. But we don't do that because we try to be nice people. Yeah. I'll give one more example of the back sub, like integral of x root x minus 1, let's say dx. Again, we don't have function derivative pairs over here, right? We have x's, we have square root, we have x minus 1, so no function derivative pairs. But if you go with the u equals x minus 1, du equals dx, try to do substitution and complete this problem on your own to get the answer. So we have the same, right? We all have the same step of the substitution. And now when you distribute u to the 1/2, you get the integral, I can do it here, integral of u, well, let me write it one more time because this is the algebra step. There we go. And then you have u to the 3/2 plus u to the 1/2 du, which is the basic integral. You just do plus 1, right? So u to the 5/2 over 5/2 plus u to the 3/2 over 3/2 plus c. Now 5/2 in the denominator goes as 2/5 in front of u to the 5/2. So now you just deal with constants first and then bring x minus 1. And that takes care of the problem. So back substitution is the part where you actually have to solve for variable and go through.
That u should be an x, right?
This is x. It's clearly an x. Because u has a completely different shape. The last part of the U sub lecture, and we are going to again review this next class for about 30-40 minutes, is the definite integral.
This is part 3.
With U sub, yeah, this is like a part 3. So we have the same problems that we had before, except now we also have limits to deal with. And before we go into solving the problems, I'm just going to remind you about the definite integral so we are understanding where this comes from. So if you want to compute area under the curve, f of x, from A to B, so you are computing this. You are going to set up the integral A to B of f of x dx. We know that from previous lectures. Now what's important for me, well, for you to know, is that this A is the x value, I'll call it x1, and B is x2 value. So those are x values. So see, x is equal to A and x is equal to B, and I'll call them 1 and 2. And this is something that you will hear me scream 50,000 times in Calc 2, Calc 3. I go x, 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 x. They all line up, right, in the same integral. Well, that means that when I do the U substitution, and you know that this changes into some different function in terms of u, and this becomes du, well, guess what? They have to change. Those numbers will most likely change from whatever you have into the new numbers that are in the u domain. Now, the good thing about that is that you don't have to go back to x. Once you swap your limits from x to u, your integral was in terms of u, your limits are in terms of u, you just compute, you get a number, right? There's no function at the end plus c. This is a definite integral. So there is actually less work with these, but you have to change the limits from x equals a and x equals b into u equals whatever the new values are. So I'm going to give you the most simple example we can think of. Say you have the integral of, let's say, x squared minus 3 and everything cubed from 0 to 2 dx. We know from the previous part of the lecture that u has to be, oh wait, I don't want x squared, I want just x minus 3 because I don't have the stuff in front for the u sub. So I have x minus 3 cubed, and then u is equal to x minus 3, and now du is equal to dx. And here's the new stuff. u1 is equal to, well, this is the u1 now location using a, and this is the substitution that connects the x world and the u world. So u1 is going to be negative 3. Well, actually, let me write it as 0 minus 3 is equal to 3, and I'll do the arrow like this. And then u2 is 2 minus 3, which is negative 1. So to change limits, simply use the substitution equation. So to change limits, use u sub equation. Great. My new integral is 0 changed to negative 3. The 2 changed into a negative 1. I have u cubed du. See, this is just a definite integral, and everything is in terms of u, including the limits. So this is where I go u, all u's. You cannot have integral in terms of u and keep x limits. Don't do that. So now we have u to the 4 over 4 computed from negative 3 to negative 1. So we have 1/4 open parenthesis negative 1 to the 4 minus negative 3 to the 4, which is 1/4 1 minus 64, and the answer is negative 63 over 4. Let's pick up. Yes?
Is it okay to find the antiderivative of this different integral in terms of x, in terms of plugging 2 and 0 instead of doing this substitution?
Well, you have to do u substitution because of the type of the problem. You have to do u sub.
The antiderivative of this is x minus 3 power 4 over 4, and then I just plug more stuff. So isn't it wrong?
I'm not sure what you're talking about. You have to use u substitution to deal with this. What are you going to do if this is 37 power? You can't FOIL it. I mean, you can, but...
It's 37, it's x minus 3, 38 over 3.
Yes.
Yeah, that's the antiderivative. And I
Oh, you're talking about this particular problem.
Yeah.
Yeah, you can do whatever. Yeah, sure. Yes. You can do the antiderivative and then go back to x variable and use x limits. Yes. But I find it easier to change the limits, and you don't have to. The biggest issue that I have, especially when teach, right, universal stuff, is students will forget. Students will forget that it was a definite integral, because you know it's wrong to put x limits on the u integral, so you don't put it, because some professors outright say in class, if you put x limits on the u substituted integral, I'm going to mark it wrong. So what do students do? They say, okay, I'm not going to put any limits there. I'm just going to remember to go back to x and compute at original limits. You will get the same answer. But see, the trick is that under the stress and all of that stuff during the exam, forget. So you have half of the classroom that, that didn't do it because they forgot that they were limited there. So, you know, again, pick your poison. Let's see some of the problems that they have in the textbook that are interesting with this. So here's problem 42. It's an amazing problem. 0 to pi over 4 of sine x over cosine squared x dx. So what's u?
One over x to the 2.
U equals
Cos?
cosine x.
I was thinking about going
What's the du?
minus negative
Negative sine
sign.
dx. Yes. So you see the dx, you don't have a negative. We'll put the negative in. Right? Negative is the... And now we have integral. There's a negative in front. And we have... What do we have? We have du over u squared. And now I'm going to change the limits. So u1 is equal to cosine of 0, which is 1. So bottom limit is 1. And u2 is cosine of pi over 4, which is root 2 over 2. And that's the top limit. Now, do you know that the root 2 over 2 is smaller than 1?
No.
And it's on top?
No.
You see that?
Yeah.
That's weird, right?
Yeah. Because it's decreasing.
Mm-hmm. But you know what? Don't despair. Didn't we learn the formula that says that if you swap the limits, what happens with the minus?
Yeah.
Right? It's gone. So, I'll just say use formula, and then we change this into, right, from being equal to negative to equal to positive, root 2 over 2 on the bottom and 1 on the top, u minus 2 du. Observe that I eliminated all of the trig and I eliminated all of the pi, whatever limits and everything else. We are now back into, right, pre-trig calculation era. So we have the integral to be u to the negative 1 over negative 1 computed from root 2 over 2 to 1. Now this is actually, I'm going to write it one more time. This is negative 1 over u. So it's simple to understand it when it's in those letters right there. So now I have a negative 1 over 1 minus negative 1 over square root of 2 over 2. So that's negative 1 plus 2 over root 2. And we rationalize this. Negative 1 plus 2 root 2 over 2, and this cancels. And we have, you can call just root 2 minus 1 as the final answer. Now, in the light of this problem, I'm just going to write it here in purple, I guess. What is the integral of tangent x dx? And I'm just going to leave it there. Like if I was to give you another exam, I just put that as 3b. You know. How do you integrate this? Is this tangent basic function? No, it's not, right? It's not on the list of our antiderivatives in 4.9. So what do I do?
Sinus x over cos.
Very good. sine x over cosine x, and then you have to use u sub. The problem we did is harder than this problem here, because you had u squared, right? Well, you are going to get ln of secant x plus tangent x plus c, but that's okay. You'll figure it out. So that's that. Let's do 15 more. Oh, actually, I want to discuss one problem before we move on. I'm going to write this one in red. It's important stuff. Pay attention. Here, star. Integral of, let's say, cosine squared x dx. There's no u sub here. Now, this integral is with us in Calc 2, and if you do not remember and memorize power-reducing formulas for PreCalc, there's nothing you can do. You must know the formulas. So the formula that you have to know is that the cosine squared x is equal to 1 plus cosine 2x over 2. And there's the one for sine, which is just a negative on top. Write it. This is absolutely a must if you are signing up for Calc 2. There is no way, there's no other way to do this integral. Well, power series and stuff, but yeah. There's no other way to do this integral other than using this formula. So now this transforms into integral of 1 plus cosine 2x over 2 dx, which kicks 1/2 outside integral of 1 plus cosine 2x dx. Now, why is this in the u sub part? Because of the 2x. But we already memorized the shortcut formula for it, so what the hell, you just use it. The integral of a cosine is? Very good. And now you can distribute this 1/2. So it's 1/2 x minus 1/4 sine 2x plus c. This is the only way. If you are really looking for u sub, go ahead, instead of using the formula, use the u sub for that cosine there. You must know these, guys. This is, yeah, you have to know this.
Isn't it like 1 over x squared or something like that? You can just flip it. X squared, so it's going to be 1 over the whole square.
Secant squared, yeah.
Secant squared.
Uh-huh.
So can we do it with that there, or that's what we need to do?
Well, there are trig identities that you can use, right? There are trig identities that you can use. There will be a whole section, 7.3, called trigonometric integrals. And in that one, you will have the first problem you do will be the problem we did, like sine to the 8x times cosine x dx. That will be like a u sub. That's, yeah. But then after that, it will be trig identities heavy. So you will have to do the reduction of power. You will have to do all of these kind of things. And then the next section is trigonometric substitution. Now this is u sub. The next one is a trig sub. So you are transforming the functions that are all given to you in x domain into sine and cosine. So you're changing it, and then you can integrate in a cosine domain, in a trig domain, and then you go back into. So all of this is going to grow. All of this is going to grow in Calc 2. First half of Calc 2 is going to be 4.9 and 5.5 prereq with the occasional derivative here and there. And then second part of the Calc 2, chapters 8 and 9, limits, every problem. Limits, 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 and then occasional derivatives later. I know. Such is life. One more problem and call it a day. This is another good problem for exam to see if you guys learned anything in class. E to the x divided by 3 plus 2 e to the x dx from 0 to ln 4. What is u? Three plus 2e to the x. And then du is 2e to the x dx. So we need a 2. Okay, so that's the first thing we fix. And now the whole problem becomes du over u. Right? And there's a half in front. Now lower limit u1, plug in 0, e to the 0 is 1, we get 5. Yay! u2, maybe I should write this down. So 3 plus 2 times e to the 0 is 5. u2, 3 plus 2 e to the ln 4 is 11. Because ln and e cancel, 2 times 4 is 8, plus 3 is 11. And now we just solve this. This is 1/2 ln of u computed from 5 to 11. That is 1/2 ln 11 minus ln 5. Now, depending on how fancy you are, and you should be fancy, you can write 1/2 ln 11 over 5 and then bring 1/2 inside for ln square root of 11 over 5. And then rationalize by root 5 to give you ln square root of 55 over 5. Or you can just leave it here. This is the boss mode. Right? It's like a peasant mode. Boss mode. And that's it. I hope you're not disappointed. This is your U-sub. Give it good 5-6 hours of your life this week. And next week we are going to start, so I'll see you all 8:30 in the morning. Providing no apocalypse or anything. 8:30, and then we'll do at least 30-40 minutes of U-sub, maybe an hour, and then I hope you will bring questions to review for final exam, which is in a week from today. Right? Well, actually not week, 10 days from today, right? 10 days. Week from today is a class, and then Thursday, 19th, 20th, 21st, what is it? 21st, thank you. So 21st is the final. See ya.